which are directly and indirectly affecting the growth and development of the rice plant or corn plants. It's the way of putting together what we are studying and placing into a process useful for decision making. So, Aesa can done by weekly field monitoring and considering different factors, which weather, natural enemies, insects or pests, weeds, radons, gas, soil condition, growth and development of the rice corn plants, fertilization, water depth, disease incidents, and insect pests. Before starting to do Aesa, make sure to observe the whole agro-system, record your general observation on the field. Randomly pick a hill and record your observation and data gathered. Get a minimum 10 sample hills in zigzag direction, at least 2 meters from the border. Then observe and record where the insects present, if the insect presence on top, mid, or sa baba. So, agro-ecosystem analysis is a systemic approach used in agriculture to study and understand the complex interaction between various components of an agricultural system. It aims to assess the ecological and environmental factors influencing agricultural production and the impact of farming practices on the surrounding ecosystem. The analysis considers the dynamic relationship between crops, soil, water, climate, and human activities in the specific farming area. Here are some key components of agro-ecosystem analysis, including biotic factors, abiotic factors, interaction and relationship, biodiversity, human factors. So first, the biotic factors. So the biotic factors this involves the study of living organisms within the agricultural system, such as crops, livestock, pests, and beneficial organisms like pollination and natural predators. Abiotic factors these factors include non-living elements that affect an ecosystem, such as soil characteristics, water availability, climate, which is temperature, rainfall, and humidity, and topography. Interaction and relationship. Agro-ecosystem analysis examines the interdependencies and relationship between different components. For instance, understanding how particular crops affect soil health or how the presence of certain insects can benefit or harm crop production. Biodiversity. The analysis takes into account the variety of plants and animal species present in the agricultural area and their roles in maintaining ecosystem balance and resilience. Human factors. Agro-ecosystem analysis also considers the human dimension of agriculture, including the farmers' practices, management techniques, socio-economic context, and cultural factors influencing agricultural decision. The goals of agro-ecosystem analysis in agriculture included sustainable farming practices. By understanding the interaction within the agricultural ecosystem, farmers can adopt more sustainable and environmental friendly practices that reduce negative impact on the ecosystem. Second, increase productivity. Analyzing agro-ecosystem helps identify ways to optimize crop and livestock production by leveraging natural processes and reducing the need of external inputs. Third is conservation of biodiversity. Assessing the agro-ecosystem allows for the promotion of biodiversity, which can be beneficial for pest control, pollination, and soil health. Resilience to climate change. Fourth is resilience to climate change. Understanding the agro-system, a dynamic helps farmers adapt to changing climate conditions and develop strategies to mitigate the effects of climate-related challenges. Then last is environmental impact assessment. Agro-ecosystem analysis assists in evaluating the environmental consequence of agricultural practices and making informed decisions to minimize negative effects. In short, agro-ecosystem analysis is an essential tool for sustainable and responsible agriculture, as it provides valuable insights into the complex relationship between the various components of an agricultural system, enabling farmers and researchers to make informed decisions for the long-term benefit of both agriculture and the environment. So, week 1. So, the general observation of reproductive corn plants. Corn or maize is an important cereal crop widely cultivated around the world for its nutrition value and economic significance. During the reproductive stage of corn plants, several key observations can provide valuable insights into their growth and development. This report explores the general observation of corn plants in the reproductive stage with a focused average plant, the number of leaves, weed color, and weed presence, specifically when the plants have high nutrients content. So, the general information is yung variety niya po is Pioneer Hybrid P4097YHR. Then, date zone is May 3, 2023. Fertilizer applied is 2 bag urea, which is 4600, and 2 bags complete 14. So, the general observation is yung weeds niya po is frequent lang. LCC is 5, which is high in nitrogen. Yung agronomic data po is age of the corn crops is 44 days. Simula po nung tinanem, nung May 3. Kinontak po namin ito nung July 16. Then, yung stage of the crop is reproductive. Then, average plant height in centimeter is 149.098. Average number of leaves is 12. The recommendation po is use insect traps po yung kailangan kasi po marami po tayong nakikita housefly during the observation. Based po sa observation namin, yung mga insect pests po including housefly and bee beetle, full armyworm, and caterpillar. Dito naman po sa natural enemies is ladybug and dragonfly. Yung dragonfly po is present sa top, yung ladybug is sa mid, yung bee beetle din sa mid, yung full armyworm is sa mid din. Yung ant po sa baba. Yung ant po is hindi na po namin nabilang kasi po madami. Average plant height. One of the primary observations in corn plants during the reproductive stage is the average plant height. In the given data, the average plant height is recorded as 149.098 cm. Plant height is an indicator of overall growth and vigor, and it can provide information about the plant's ability to assess light and other sources. Higher plant height is generally associated with better nutrient availability and favorable growing conditions. In this case, the relatively tall plant height suggests that the corn plants have been growing well and are likely benefiting from favorable environmental conditions and adequate nutrition supply, including high nitrogen content. So the next is number of leaves. Another important observation in corn plants during the reproductive stage is the average number of leaves. According to the provided data, the average number of leaves is 12. Leaf production is critical for photosynthesis and nutrients uptake in plants. As corn plants transition into the reproductive stage, the number of leaves may stabilize or slightly decrease as the plant diverts energy towards reproductive structures such as tassels, and ears. However, the presence of an average of 12 leaves suggests a healthy plant with sufficient photosynthesis capacity to support reproductive processes. So next is leaf color. Leaf color can provide valuable information about the nutritional status of plants. In this case, the leaf color charts indicates an average score of 5, which suggests a healthy green color. The green color of corn leaves is primarily attributed to chlorophyll, the pigment responsible for photosynthesis. A high leaf color score indicates that the corn plants are likely receiving adequate nitrogen, an essential nutrient for chlorophyll production. Nitrogen is vital for overall plant growth and development, as it is involved in protein synthesis, enzyme activities, and various metabolic processes. And the healthy leaf color further confirms that the corn plants have sufficient nitrogen supply. So, the presence of weeds is an important observation in any crop field, including corn. Weeds compete with crop plants for resource resources such as water, nutrients, and sunlight. In the given data, it is mentioned that weeds are the frequent stage. Frequent weed presence can negatively impact the growth and yield potential of corn plants. Weeds can hinder proper nutrition uptake, reduce light penetration, and even serve as hosts for pests and diseases. Effective weed management strategies such as timely and appropriate herbicide application or manual removal are crucial to minimize weed competition and ensure the optimal growth of corn plants. In short, the general observation of corn plants in the reproductive stage with high nitrogen nutrient content provided valuable insights into the growth and development. The average plant height, which is 149.098 centimeters, suggests favorable growth condition and nutrient availability. The average number of leaves being 12 indicates a healthy plant with sufficient photosynthesis capacity. So, the leaf color chart scores of 5 confirms a healthy green color indicating an adequate nitrogen supply. However, the presence of weeds in the frequent stage highlights the importance of effective weeds management strategies to minimize competition and minimize the yield potential of corn plants. These observations collectively contribute to understanding the overall health and productivity of corn plants during the reproductive stage.
Agro-ecosystem analysis plays a vital role in understanding the health and productivity of agricultural crops. On June 30, 2023, an assessment was conducted on corn crops to evaluate their growth and performance.
So ito po yung week 2 namin, week 2 ng pagko-conduct ng Aesa sa corn crops. Wala na pong in-apply ng fertilizer simula nung first week hanggang June 30. Then, the general observation po namin is frequent presence of weeds pa rin, LCC is 5. Agronomic data is age of rice plants is 58 days simula nung na-sown, which is May 3, 2023. Then, average plant height is 205.994 centimeter. Average number of leaves is 12. Then, recommendation is monitoring. Then, the natural anim space is spider. Then, yung insect pest is fall armyworm.
Based on agro-ecosystem analysis conducted on June 30, several key observations can be made. So, first, good growth indicators. The corn crops displayed promising growth indicators with an average height of 205.994 cm and an average of 11.6 leaves. These parameters suggest that the plants were growing well and had entered a stage conducive to a healthy reproductive phase. Second is optical nitrogen levels. The LCC rating of 5 indicates that the corn plants were receiving adequate nitrogen supply. Sufficient nitrogen is essential for enhancing vegetative growth and maximizing yield potential. The agro-ecosystem analysis conducted on June 30 provides valuable insights into the status of corn crops. Overall, the crops appears to be thriving with favorable average height, leaf count, and nitrogen levels. In our observation about conducting an agro-ecosystem analysis in week 1 and 2, we saw that some of the crops were affected by some pests. Conducting an agro-ecosystem analysis is a crucial step in understanding the dynamic of agriculture system and identify the factors that affect crop health and productivity. Our observation of pests affecting corn crops highlights a common and significant challenge faced by farmers and agricultural experts worldwide. Here are some key points to discuss regarding our observation. First, importance of agro-ecosystem analysis. Agro-ecosystem analysis involves studying the interactions between various components within an agriculture system, such as crops, pests, soil, weather, and human activities. By understanding this interaction, farmers can make informed decisions and adopt sustainable practices that promote crop health and productivity. Number 2, Pest management in agriculture. The presence of pests in corn crops can lead to reduced yields, lower crop quality, and financial losses for farmers. Pests can include insects, disease, weeds, and other organisms that negatively impact crop growth. Implementing effective pest management strategies is essential to minimize crop losses and ensure food security. Third, identify the specific pest. In our observation, it's essential to identify the specific pests that affected the corn crops. Different pests have unique behaviors in life cycles, which influence the most appropriate pest management approach. Proper pest identification enables targeted and effective control measures. Support Integrated Pest Management or IPM. IPM is a holistic approach to pest management that combines various techniques to control pests while minimizing negative impacts on the environment and human health. IPM strategies may include biological control using natural predators or parasites, cultural practices or crop rotation or intercropping, physical barriers, and judicious use of chemical pesticide when necessary. Number 5, environmental factors. An agro-ecosystem analysis also considered environmental factors that could contribute to pest outbreaks. These factors may include climate condition, soil health, nearby habitats, and surrounding land use. For instance, specific weather patterns can favor the proliferation of certain pests, while soil nutrients imbalance might we taken crop resilience against pest attacks. Number 6. Sustainable practices. The observation of pest issues underscores the importance of adopting sustainable agriculture practices. Sustainable agriculture focuses on maintaining productivity while preserving natural resources and ecological balance. Examples of sustainable practices include crop diversification, the use of organic fertilizer, maintaining beneficial insect populations, and reducing reliance on chemical pesticides. Number 7. Monitoring and early detection. Regular monitoring of crop health is vital to detect pest infestations or diseases early on. Early detection allows for timely intervention, which is often more effective and less costly than trying to control well-established pest populations. Number 8. Research and knowledge sharing. Continual research and knowledge sharing within the agricultural community play a crucial role in improving pest management practices. This includes disseminating information about pest-resistant crop varieties, best practices, and emerging technologies to enhance agricultural resilience. Our observation of pests affecting corn crops highlights the importance of conducting agro-ecosystem analysis and adopting sustainable pest management practices in agriculture. By understanding the complexities of the agricultural system and integrated various strategies, farmers can mitigate the impact of pests and cultivate healthier, more productive crops.
So before I proceed to this presentation of food web, I will discuss the importance of food web. The food web is a vital importance in corn crops because it influences the overall health and sustainability of agricultural ecosystem. A food web is a complex network of interconnected food chains representing the flow of energy and nutrients among various organisms in an ecosystem. In the context of corn crops, the food web involves interaction between plants, herbivores, predators, decomposers, and other organisms. So, ang mga kumakain po sa corn plants ay fall armyworm, grasshopper, and ant. Ang kumakain naman po sa ant ay bird at dragonfly. Sa housefly naman po, ang kumakain sa kanya ay dragonfly, lynx spider, bird, and toad. Sa pibitan po is ladybug. Ang kumakain po sa ladybug ay bird and
chain. What is the food chain? A food chain refers to the order of events in an ecosystem, where one living organism eats another organism, and later that organism is consumed by another larger organism. The flow of nutrients and energy from one organism to another at different trophic levels forms a food chain. What is the importance of food chain? Food chains are important because they show the intricate relationships in ecosystems. They can reveal how each organism depends on someone else for survival. Food chains also display what happens when a problem occurs and a procedure or consumer is lost. Yung corn, kakainin siya ng fall armyworm. Yung fall armyworm, kakainin siya ng ladybug. Pagka namatay yung ladybug, kakainin siya ng langgam. Yung palaka, possible na kainin niya rin yung langgam. Pagka namatay naman yung palaka, kakainin siya ng uwak. Pag namatay naman yung uwak, magiging decomposer siya at lututubo yung mais.
Food pyramid. Food pyramid is a graphical representation showing the relationship between different organisms in an ecosystem. It shows the flows of energy at different trophic level in an grasshopper. In the food pyramid is a primary consumer. The product in the food pyramid is a secondary consumer because it eats the primary consumer, the grasshopper. The product in the food pyramid is the tertiary consumer because it's the secondary consumer. Halimbawa, tertiary consumer, toad. Kakainin yung secondary consumer na ant. At yung ant, pwedeng kainin yung primary consumer na moth. At ang pinaka-primary consumer nila ay yung corn.
I'm Pauline Isabel Campo.
I'm Caitlin Valeria.
I'm Jana Maiko.
May bibigawin ko
And we are Group 6 from Misa 1B.